Good afternoon to everyone. Today we are going to continue our chapter, Some Gases. Today it is the second day or last day we can say of this chapter. That is, today we learn about ammonia gas, carbon dioxide. We have learned in the previous class. Today we learn about ammonia gas. Oh, so ammonia. You all are well known about ammonia. That is molecular formula NH3. One atom of nitrogen and three atoms of hydrogen. They combine together to form ammonia molecule. Okay, both of them, nitrogen and hydrogen, both of them are non-metal and they form covalent bond between them. So nitrogen atomic weight is 14 because there are 7 proton and 7 neutron, and hydrogen atomic weight is 1 and there are 3 hydrogen atoms, so 3 into 1, that is 3, and nitrogen has atomic weight 14, so 14 plus 3, that will give you 70. And first of all, this ammonia gas was prepared by Lavoisier, okay, by heating the mixture of ammonium chloride and calcium hydroxide. For this reaction we learn later. So occurrence of ammonia. How is ammonia found in nature? Ammonia is found, okay, ammonia gas is found in nature freely also or in the form of mixture also. So freely, you know that the gas produced by from nitrogenous materials like these dead plants, okay, when the dead plants are decomposed by decomposer, they release a gas in the absence of oxygen, that is ammonia. So that is in free state. Not only that, ammonia gas is found in nature in the combined state of mixture form, that is in ammonium chloride, ammonium sulfate, ammonium nitrate, etc. Okay, so now we are going to learn about laboratory preparation of ammonia gas. How can we prepare ammonia gas in laboratory? Okay, so for that, when a mixture of ammonium chloride and calcium hydroxide, okay, that ratio should be 2 is to 1, means 2 part ammonium chloride, 1 part calcium hydroxide. Here calcium hydroxide, that is taken in the form of solid, okay, hydrated calcium hydroxide. So ammonium chloride is a solid, calcium hydroxide another solid, and that should be taken in the ratio 2 is to 1, means 2 gram ammonium chloride is there, then 1 gram calcium hydroxide. If 4 gram ammonium chloride is there, then 2 gram calcium hydroxide. In this ratio, we have to select these materials and then we have to heat it in a container like a hard glass test tube to get ammonia gas. So if you see here, ammonium chloride and calcium hydroxide, both of them are compound. So here is double displacement reaction. So here what will happen? This ammonium will combine with hydroxide. Okay, hydroxide is a negative radical. So this positive radical, electropositive radical, combines with electronegative radical and forming ammonium hydroxide. If you remember, in the previous class, I told you that when there is formation of carbonic acid H2CO3 in the product, then we have to break it into water molecule and carbon dioxide. Here if you are observing, then here will form NH4 and OH. So NH4OH, and that will give you NH4OH, and if there is the formation of NH4OH in the product, in that condition you break it into ammonia, NH3 and water. It means if anywhere we are getting NH4OH in the product, we will write there NH3 and H2O. Okay, and rest one living here is Cl and Ca, but we have to write positive first, so Ca is positive and Cl is negative, and by taking Ca first and Cl later, and by crisscross method you will get CaCl2. So this is, and later you can balance it after then. So this is figure for laboratory preparation of ammonia gas. Okay, so procedure, what is done here, you all are well known. We have to take first all the material that should be washed, cleaned and dried properly. After then you have to take a hard glass test tube. In that test tube you have to put ammonium chloride and calcium hydroxide in the ratio 2:1. Okay, then we have to clamp this hard glass test tube with the help of clamper or iron stand, like as shown in the figure. And the mouth of the hard glass test tube, okay, here you can see this mouth should be slightly tilted downward. थोड़े tilt गरेको छु मैले तल, है, so slightly tilted downward so that the produced water molecules will escape out from there. After then, that means what will happen here? And this cork is fitted with a delivery tube, and one end of the delivery tube is in this tube, and another end is set up into this lime tower. A lime tower contains lime, calcium oxide, quick lime we used to say. Okay, so here is the presence of quick lime in this tower. After then, the tube is set here so that gas can be passed easily to the gas jar. It would not move here and there, just directly go up. And carbon dioxide, sorry, this ammonia gas is lighter than air. Okay, so it will move upward. Lighter than air means move up. So it will move up and occupy the upper this space of this one gas jar. Okay, and the air near it rises near it moves out, because as this place is occupied by ammonia gas, the air near to it moves out, and that's why here the air moves downward, and so written here downward displacement of air, and here is lighter than air. Okay, so first of all, after arranging this apparatus, we have to heat this mixer with the help of this burner, and when Bunsen burner is called connected with gas, so and it produces a large amount of heat. That heat start this reaction between ammonium chloride and calcium hydroxide, and ammonia gas is produced, and that gas, obviously there is production of water molecule also. So this gas contains some water molecules, and so that water molecules is absorbed by this lime tower, and that's why we require lime tower, so that this air molecule present in the this ammonia, that is absorbed by this lime, and only dry ammonia can be collected in the gas jar. So, and after then we require the precautions, and precautions, you know that as usual, as the apparatus should be clean and dry. Not only that, the apparatus should be made airtight, otherwise gas will move outside. It should be supplied uniformly. Uniform heat supplied helps to sorry, does not allow to crack the tube, hard glass test tube. The mouth of hard glass test tube should be slightly tilted downward from the horizontal to prevent it from cracking due to evaporation of water produced during chemical reaction. Everyone is okay. So ammonia gas should be passed through lime tower to get dry ammonia. Okay, ammonia is lighter than air and highly soluble in water, so it should be collected by downward displacement of air. Okay, after then, general method to prepare ammonia gas. How can we prepare ammonia gas generally? So one of them is by heating. So ammonium gas is prepared by heating ammonium salt, such as ammonium sulfate, ammonium chloride, ammonium nitrate. So this, if you are going to heat it, then like ammonium sulfate, when we supply heat, it is gives ammonium bisulfate and ammonia gas. In the same way, if you are going to heat ammonium carbonate, that is solid, you know that it is for solid, G for gas, L for liquid. So when you are going to heat ammonium carbonate, it will gives you ammonia, water and carbon dioxide. So it means this reaction, ammonium carbonate, can be used for general preparation of carbon dioxide also, and general preparation of ammonia gas also, because here is uh, both production of ammonia and carbon dioxide. After that, when ammonium salt, just we are discussing here, ammonium sulfate, ammonium carbonate, ammonium phosphate, ammonium nitrate, they are ammonium salt, means salt containing ammonium radical. So when it is treated with alkali, NaOH, KaOH, CaOH2, MgOH2, whatever, so in that condition it produces ammonia gas. So in the same way here you can use again, so ammonium and hydroxide, so NH4 will combine with OH, so this will result you NH3 and water, as I have told you. And after then Na and sulfate will leave, so Na has valency 1, And sulfate has valency too, so it will form molecular formula Na2SO4. In the same way, NH4Cl plus KOH. Again, NH4 will combine with OH. NH4 has valency 1, OH has valency 1. So it will give you NH4OH, and that NH4OH will break up into NH3 and water, leaving K and Cl. So K and Cl will combine, and that will result KCl, potassium chloride. Okay. After then, manufacture of ammonia gas. How can we manufacture? How can you prepare ammonia gas in large scale so that we can sell it for commercial purpose? Okay. So for that, this German chemist Friedrich Haber, the name of German chemist, he introduced this idea, that idea for manufacturing ammonia gas in large scale. Okay, and that's why this process is also called Haber's process. About this Haber's process, if you join science system in 11-12, then you learn it in there how ammonia gas is prepared with diagram and every other things. Okay, so till then just know. So ammonia gas is manufactured for the commercial purpose by heating nitrogen and hydrogen gas. Nitrogen 1 ratio and hydrogen 3 ratio. Nitrogen and hydrogen in the ratio 1 is to 3 under suitable condition. Okay. So it is also produced during this reaction. So first of all, we have to supply heat. Later it is also produced. Okay. So N2 nitrogen 3s2 means balancing for that, and ammonia gas is produced here. Okay. After then, but obviously you see here the arrow. Here is arrow in both the direction, this side also and this side also. So this reaction is called a reversible reaction, where reactants can be changed into product, product can be reversed to reactants. That is called a reversible reaction. So here is this arrow represents a reversible reaction. So this is the above reaction is reversible reaction, but this reaction is too slow. Okay, not only reversible, too slow. If you are going to just perform this preparation of this gas in low normal temperature, that then it's too slow reaction, and that's why. But we require large amount of ammonia gas, and that's why for the large scale we require some conditions. So you can see here the conditions. Temperature, we have to supply here some temperature, that is 500 degrees C. Pressure about 250 atmospheric pressure. Catalyst iron dust, and promoter molybdenum. Okay, so here why catalyst and pro? What is the meaning of promoter? Actually, promoter also acts as catalyst, but not exactly catalyst. Listen properly. Catalyst, here is catalyst is the iron dust, and iron dust is solid in nature, and it cannot initiate the reaction as quickly, or it cannot initiate the reaction. So for that, to make it more efficient, iron dust, okay, as catalyst, to make it more efficient means to make catalyst more efficient, we have to add molybdenum, and molybdenum increases the efficiency of this catalyst, and so that iron dust can work as catalyst. So molybdenum just promote the catalyst, does not take part, but promote this iron dust to help in the chemical reaction. That's why molybdenum is promoter only. Promoter just increases the efficiency of catalyst. Okay. After then, and here is written, high pressure should not be generated to prepare ammonia gas. No, for large scale we can generate to pressure. Why 250? Why not 200 to 2500? More than 1000. So if we are increasing more and more pressure, then equipments may be damaged, and that's why only limited pressure, that is 250 as mentioned in our book, that should be maintained there. After this, test of ammonia gas. How can we test ammonia gas? Okay, like carbon dioxide, we can test ammonia gas also. It also does not support burning, so we can do by gas also, but that is not the proper way. So one of them is ammonia gas. So NH3, and as I have told you, NH3 are dissolved in water, it means it forms NH4OH. And we have learned, if there is OH ion in the compound, then that is a base or alkali. It means NH4OH is a base, and that is formed by the combination of ammonia and water. Water is a neutral substance, and that means what ammonia is here basic in nature, so that NH4OH will be a basic substance. And so we here is written ammonia gas is basic in nature. So when a moist red litmus paper is inserted in the gas jar containing ammonia gas, like previous already explained, so it turns, as it is basic, so it turns red litmus paper into blue color. And if that is changed, it means the gas should be ammonia. Next one, just take a glass rod and dip it in a container containing concentrated hydrochloric acid. Now there is few attachment of this concentrated hydrochloric acid in the glass rod. Now if you are going to pass this glass rod to the gas jar or the test tube containing ammonia gas, then after then there is a formation of white fumes. Okay, जब तिमीले ग्यास जारमा पहिलेदेखि एमोनिया ग्यास तिमीसँग रेडी छ, टेस्ट ट्युबमा रेडी छ भने अब तिमीले हार्ड ग्लास टेस्ट के अरे कुनै ग्लास रडलाई चाहिँ जब तिमीले हाइड्रोक्लोरिक एसिड कन्सन्ट्रेटेड हाइड्रोक्लोरिक एसिडमा डिप गरेको ग्लास रडलाई यो ग्यास जारमा पास गरायो भने त्यहाँ चाहिँ व्हाइट फ्युम फर्म हुन्छ. इफ द्याट इज produced, it means that gas must be ammonia gas because that forms ammonium chloride as a white fume. Okay, so that is the sure test for ammonia gas. After then, physical properties of ammonia gas. Physical properties: it is colorless gas with strong pungent smell which may produce tears in eyes. Means we can't see this gas, but very hard smell. Okay, too much hard smell, and that hard smell can burn our eyes and means produces tears in our eyes. Okay, after then it turns red litmus paper into blue, that basic in nature. It is highly soluble in water. It is lighter than air. It is neither combustible nor supporter of combustion. न बल्छ न बल्न दिने. Chemical properties of ammonia gas. How can we use ammonia gas for different purposes? So one of them, ammonia gas is highly soluble in water, so it forms ammonium hydroxide when dissolved in water. Ammonium hydroxide forms as an alkali. Okay, this is only alkali which does not contain any metal. After then, ammonia reacts with acid to give respective salts. So ammonia, let's take NH3 and take any acid, HCl, H2SO4 or HNO3, any acid, then that will, this is the combination reaction. So NH3 will combine with H2SO4 and it will form ammonium sulfate. Another one, ammonia combines with nitric acid and it will form ammonium nitrate. If you are taking here NH3 plus HCl, then it will result NH4Cl, that is ammonium chloride. Okay. After then, when ammonium hydroxide is the base, reacts with a strong acid, means hydrochloric acid, nitric acid, sulfuric acid. If we are going to come, means ammonium hydroxide, that is, we can say uh, ammonium hydroxide, that is base, and strong acid means that is acid. So acid and base results salt and water. So if you see here NH4OH plus HCl, that is NH4Cl, ammonium chloride, that is salt, and H and OH, that will result water. Another NH4OH plus H2SO4. So this will result you NH4 whole 2 SO4, ammonium sulfate, and another is water. Okay. So another one NH4OH plus HNO3, that will result to ammonium nitrate and water. About this molecular formula now I am not going to explain. So another one, this another reaction is for both carbon dioxide and ammonia because it contains this reaction belongs to both carbon dioxide and ammonia gas. So let's look here. When a mixture of carbon dioxide and ammonia gas are heated, mixture, if you are going to heat the mixture at about 1500 degrees C, when a mixture of carbon dioxide and ammonia gas are heated at about 1500 degrees C and certain pressure, then urea is obtained. Here you can see CO2, that is carbon dioxide, so that is chemical properties of carbon dioxide. Also you can use NH3, that is chemical properties of, we can use for ammonia. And if you heat it in the presence of pressure, then it will form NH2CONH2. This one, NH2CONH2, this is urea. You know that urea is used as fertilizer. खेतमा मलको रूपमा युज गर्छ. So this is urea, and then water molecule. Okay. Now, ammonia reacts with concentrated hydrochloric acid and forms solid ammonium chloride, as I have already explained. अघि हामीले भनेका थियौँ एमोनियालाई चाहिँ एमोनिया ग्यासमा चाहिँ कन्सन्ट्रेटेड हाइड्रोक्लोरिक एसिडमा पास डुबाएको रडलाई पास गर्यो भने व्हाइट कलरको फिल्म दिन्छ एमोनियम क्लोराइड. ओके. And ammonia reacts with oxygen. एमोनियाले अक्सिजनसँग पनि रिएक्ट गर्छ and it forms greenish yellow flame which contains nitrogen and water. So यो रिएक्सन तिमीले घोक्ने हो. So ammonia NH3 plus water give you, sorry, oxygen give you water and nitrogen. But it is a mixture of nitrogen and water, and that's why it is greenish yellow in flame. Okay. After then, moving to next. This is usage of ammonia gas. So what are the uses? It is used to manufacture chemical fertilizers such as urea, ammonium sulfate, ammonium nitrate, ammonium phosphate, etc. Okay, liquid ammonia. Liquid ammonia can be obtained by cooling drying dry ammonia near about minus 42 degrees C, and we'll get liquid ammonia. And liquid ammonia is used as a refrigerant in a refrigerator, cooling agent in a refrigerator. Refrigerant cooling agent. It is used to prepare nitric acid, HNO3, because there is ammonia NH3, so that HNO3, nitric acid, plastic, washing soda. Okay, next one. It is used to develop the blueprint of map. यो चाहिँ के हुन्छ भने हाम्रो नापी विभागमा हाम्रो नक्सा निकाल्ने ठाउँमा म्यापको ब्लुप्रिन्ट निकाल्नु पर्यो भने अथवा अरू ठाउँमा पनि निकाल्दियो भने कुनै ठाउँमा नक्सा निकाल्नु ब्लुप्रिन्ट नै चाहियो भने मेनली चाहिँ नापी शाखाले गर्ने हो. सो देयर ammonia gas is used to develop the blueprint. Okay, it is used as cleansing agent to remove oil greaseहरु सब हाम्रो छुटिरहेको हुँदैन कुनै पार्टमा लागेको छ भने छुटेको छैन भने त्यो बेलामा चाहिँ यसलाई युज गरेर हामी oil र greaseलाई remove गर्न सक्छौं. And next one, it is used for manufacturing ammonium salt. Already we have discussed different types of salts are formed when ammonium hydroxide combines with acid due to dissolves ammonium salt. So NH4OH plus HCl, that will give you NH4Cl. NH4OH plus H2SO4 gives you NH4 So ammonium salts such as ammonium chloride and ammonium sulfates, they are used as medicine. Okay, so this is all about ammonia gas. I'll stop sharing.